Okay, in this video, we're going to go through the homework for exercise 2.4. So let's start with question 2. We have a mathematics exam, papers 1 and 2. Full score is 100 each paper. Now, he scored 57 in paper 1. Total score has to be at least 120 in order to pass. They want to know what he should score in paper 2. So we let our unknown be the score in paper 2. Let x be score in paper 2. So now we are trying to find out what the total score is. Total score will be 57 plus x. We want this value to be greater than 120 in order to pass. Therefore, x has to have a value of greater than or equal to 120. So greater than or equal to 63. Alright. What he should score is he should score greater than or equal to 63. There is no need to put less than 100 or less than or equal to 100 because the question already mentioned, the question has already limited the maximum to be 100. So there's no way you're going to go past that. So now let's carry on with question number 2. The second question, which is number 6. Okay, so we have a rectangular playground, x meters long, y meters wide. And each of these x and y value, there's a boundaries. So part A, perimeter, will be 2x plus 2y. So 2 lengths plus 2 breadths. This is in meters. Now in part B, they want the minimum perimeter. So we take the smallest values of x and the smallest value of y. So 2 times of 20 plus 2 times of 15. So that gives us 40 plus 30, 70 meters. And part C, maximum perimeter. Now we're going to take the upper values. For x values, highest is 30, and for the y value, highest is 18. So that gives us 36 plus 60. So that is 96 meters. Now we go to the next question, number 8. So here, the question is talking about looking at the volume of a cylinder, but instead of giving you all the information, they only tell you the base area and they do not give you the height. Since they want you to find the range of possible values of height, we let height be h cm. Sometimes it's useful for you to draw a diagram to visualize as well. So we let this be the height, and the base area, they told us that it is 50 square centimeters. They want us to consider the volume of water. So volume, base area times height. So this is in cubic centimeter. Then there's a limitation. They want the volume to be at least 200 cubic centimeters. So it can be 200 or more than that. So our lower bound is 200. Then we have our volume. And they want it to be not more than 320. So it can be 320. So this is our inequality. And we cannot replace our volume with 50H. Now on both sides of the inequalities, we are going to divide by 50. Since it is a positive value, there's no reason to change any of the inequality signs. So 200 divided by 50, we get 4. The height will be in terms of centimeters. So now we know that the lowest possible height is 4 centimeters. And 320 divided by 50, we get 6.4. Okay, now to answer the question, find the range of possible values or possible heights. Let's replace the h back with our height. 6.4 cm, 4 cm. Now next question, 11. They gave us the 3 sides of the triangles, but they are all in terms of x, so we don't exactly know any of the sides. But they did tell us that the sum of 2 sides of a triangle is greater than the third, any 2 sides. So we are going to have to test out all 3 pairs of sides of the triangle. So let's start with the first pair. Just randomly choose 2. For me, I'll choose x minus 11 plus. The other one is x minus 8. This is supposed to be greater than. Okay, the printing is not very clear. Okay, now it's there. Supposed to be greater than x plus 4. This is the first inequality that I can write. The next inequality, I'll leave some space over here so I can solve it. The next inequality that I can write is x minus 8 plus x plus 4. This has to be greater than x minus 11, which is the other side. So leave some space again. The final inequality that we could have, x plus 4 plus x minus 11, this has to be greater than x minus 8. So for a triangle, all 3 of these inequalities have to be fulfilled before we are able to say that these 3 sides give us a proper triangle. So let's start with the first one. We've got x plus x, that gives us 2x, minus 11 minus 8, so minus 19, is greater than x plus 4. So you solve this, you end up with x greater than 23. So we have one solution over here. The next one, 2x minus 12 greater than x minus 11. Solving this, we get x is greater than, this is x minus 8, x plus 4. Okay, so a small arrow over there. On the left hand side, 2x minus 4, yes. So then we end up with x is greater than negative 11 plus 4, we get negative 7. So this is the second inequality that we must satisfy. And then the final one, 2x minus 7 greater than x minus 8. So solving this gives us x greater than negative 8 plus 7, negative 1. So with these 3 inequalities, all of them have to be solved, satisfied at the same time. We do our usual number line, put in the 3 values, negative 7, negative 1, and 23. With all the arrows pointing to the right, since all of them show that x is greater than 23, x is greater than negative 7, x is greater than negative 1. And instead of our usual 3 regions, we now have 4 regions. And only this region here satisfies all 3 at the same time. Therefore, our conclusion is that x has to be bigger than 23. And now we come to the final question. Okay, so question 14. We have a car that can drive from one place to another, either via route x or y. So route x is 1 km shorter than y, speed of x is 60 kilometers per hour, route on y, the speed on y is 50 kilometers per hour. So right now, we can see that route x is shorter and the speed is higher. Route y is longer, the speed is lower. Therefore, if you talk about the time taken for x is definitely smaller than the time for y. So if you didn't get that, just rewind this bit again. Okay, then they want to find the shortest driving distance of x, such that blah blah blah. So we let distance of root x be equal to x km. So since I now have an expression for distance of root x, then therefore distance of root y is x plus 1 km. It is longer. We also have the speed for both of them. So remember your dst. You have speed, you have expression for distance, you can obtain one for time. So time for root x, we take the distance divided by the speed. Okay, so we now have an expression for both of them. Now they want to find the shortest distance such that the time for x is at least 8 minutes less than that along y. So since we are doing a comparison of time, we want to do a subtraction. Then when we do a subtraction, we take the bigger value minus the smaller value. So we said that the time for y is going to be bigger. It takes a longer time. So our x plus 1 over 50 minus away your x over 60. This is the difference in the time. They want it to be at least. So at least symbol greater than or equal to 8 minutes. But we have everything in terms of hours. So let's change our 8 minutes to hours. So 8 over 60. So now to continue, I'm going to multiply everything by 300 because if I multiply by 300 everywhere, all the denominators will disappear. So if you cannot understand this part, you just multiply everything by 50 first, then multiply everything by 60. It has the same effect. Okay, so multiplying by 300, I get 60 x plus 60 minus 50 greater than or equal to 400. Sorry, minus 50x here. So on the left hand side, we have 10x. I'm going to subtract 60 on both sides. So I'm left with 340. Now we divide by 10. We get x is greater than 34. Greater than or equal to 34. So now they want the smallest value of x. Therefore, shortest distance is 34 kilometers.